DC power. Okay. Hopefully that answered your question, cute puppies. Now, can I get it off the screen? Huh. There we go. Okay. So I am going to move on to part 3 of the live stream today. And if you have any other questions, feel free to ask them. Part 3 is, how many solar panels do you really need? And this is probably the number one question, and it kind of goes back to what we talked about a little earlier, but the number one question I get is, how many solar panels do I actually need? Usually asked by somebody who's new and has already bought some and they didn't end up being enough. So the answer isn't the same for everyone, because there isn't a fixed amount of usage for everyone. Most people buy too few, thinking use it for one reason or another. They see, okay, I've got 2,000 watts of solar panels and I'm only running 1,000 watts in my, they measure how much they're using and they see 1,000 watts of usage and 2,000 watts of panels, and they decide, hey, they don't need anything more. When in reality, they're using half of what they're generating. The other half is going into the battery, and a lot of it's getting lost in inverter cost and conversion cost and stuff like that. So in this discussion here, we'll kind of go over how you can figure it out step by step of how much you really need. So you want to start with an audit. And what do you actually use daily? And I mean total, not what's solar power, what's this power. Really, truly, what's that? If you're in a house, this is pretty easy. You can go out and read your meter, and you can read your meter a couple of days in a row and you can see it. You can look at your electric bill and it'll tell you how much you use. You can do measurements. There are cool, I've got some videos coming out on some cool devices that you can hook up in your breaker panel box. I did a build of a 240 volt, 50 amp metering system that you can hook up for your RV to determine what you're using there. There's a ton of different ways to actually figure out what your true energy usage is. You can also estimate this based on paper. Most devices will tell you either the watts that they use, and based on how much you use them, you can determine how many watt hours you're going to be using. If you've got and if they don't tell you wattage, most of them will tell you amperage. And if you're going to do any type of solar project, the sooner you learn that amps times volts equals watts, and every algebraic formula that you can come up with to use that is going to be very useful for you. In other words, if you've got 2 amps and it's a 120 volt device, it's using 240 volts, because 120 times 2 is 240. So it's 240 watts. That formula you will use nonstop. You might as well do whatever you have to do to memorize it. I know it sounds like school again, but it's going to be something that you use quite a bit. You can take all of those calculations if you want to divide and break down all your individual devices, or you can just take the use from your whole entire house off your bill and come up with how much you're going to need and convert that into watt hours or kilowatt hours, and then that will allow you to know how much size battery power you're going to need and how to do it. The factor here of panel losses from heat and wiring and all of that is something that you're going to need to calculate in. You don't assume that just because you have 1,000 watts of solar power that you're going to get 1,000 watts to use out of it. Most likely, you're going to take that solar power and it's going to go into an inverter, and the inverter is going to have some losses to give it to you back in AC where it's usable. Or you're going to convert it from the solar panel wattage, and you're going to put it into a battery, and the battery is not going to be 100% efficient and can't store all of it, and it may be 98% efficient, but even 2% over time adds up, and you'll be surprised how much the add up is there. Also, you're going to have to take into account solar peak hours and stuff like that. Now, I'm going to put a QR code up here on the screen. Messed with my video screen a minute ago and moved one of the items off, so there it goes. Okay, so there's the QR code for, where is that, the one for this one? Yeah. There we go. There's the QR code for this one. And I'm going to go over to it, and we're going to see if we can, I'm going to take you to a little website that is included in there. So we go to, there's a website there called PVWatts.rl.gov, and this is a website that is very useful. Let me see if I can get this site up, and then I'll switch it to where you can see what I'm doing here. Once I know that I'm not going to be going, oh, why in the world did I do that? All right. So this website, switch this here to this screen. That's the right one. There we go. So you should be able to see it now. So on this website, this is a really cool website because what you can do is you can come up with your zip code. And let's say that you are in Cocoa Beach here, so 32932, let's say. And I'm broadcasting from my wife's coffee shop here in Cocoa Beach today, across the street from Ron John's. If you're ever in the area, make sure you come in, tell her hello, and tell her you saw me, and then I said to come visit her. So this website is really cool because you can use this to kind of get an idea. How many panels do you really need? And it takes into account some of the things that are going to affect you. So I picked Cocoa Beach here, and you can see it takes into account the longitude and latitude of it, and you just go to the next location. Here it's asking you for how many panels. Now I'm going to use my RV as an example here, and I've got 3.7 kilowatts. Now keep in mind this is talking kilowatts, so that's 3,700 watts of power is 3.7 kilowatts. And the module types are standard module, premium module, or thin. I'm just going to say they're standard, and then it's going to ask, are they fixed, open rack mounted? Are they mounted on a roof mount? Or do they have axis tracking? And the reason they're asking this is because all these different types of mounts can affect the performance and how much energy you can actually get from them. So I'm going to say they're open rack because they're mounted on my RV. And you'll notice here that it's got a automatic loss calculator put in, and I've learned that 14% is pretty close to right for taking solar energy, doing the conversion, getting it into a battery, and that kind of thing. You may need to do it, change it a little bit. This tilt degree based on where you have them. If you've got them mounted on the side of a building, then they would be at 90 degrees. If you've got them mounted flat on top of an RV like I do, then they would be 0 degrees. This is the turn towards to where the sun is and what angle they're going to be going at. Because they're mounted flat, it doesn't make any difference for me. But if in your area, you're going to want to make sure that you point that to the right angle and adjust that to come up with the right calculation. There's detailed information on how that would be done. And then from here, I wonder if I can make that a little bit bigger for you. Oh, that worked out really well. Okay, so from here you can go next, and this is going to give you a chart of what it would expect this to generate in any given month based on your location and based on that performance. Now you can, if you've got multiple arrays, you can put in multiple calculations, change the angles, change the turn, change how many panels there are, and all of that kind of stuff, and then you can add them all together. But just to kind of give us an idea of how accurate this is, so this says in August that we should have generated about 531 kilowatt hours. So I'm going to run over here to my energy board here. Now these are only the solar panels that are mounted on the roof. This doesn't include the solar shed. So we're going to look at just this Lux Power PV Energy not the Victron, because the Victron is the solar shed power. And we're going to go back to last month. Oh, that's just looking at a day. Let's go to this month, and then let's go back to last month. Okay, so last month, and then we're going to scroll down here to how much power was generated, and I've got 498 kilowatts. So it looks like I've probably got just this is showing it a little bit more efficient, and what that most likely is I do have one panel that points north a little bit at the front of the RV. So that inefficiency isn't being accounted for here. Now, if you're talking about a fixed setup that you would have in your backyard or on your house, it will probably be close enough. This gets you in the ballpark. It doesn't get you a perfect answer, but it does give you an idea of, I could look at and say, look, I'm probably going to be generating somewhere around 5,455 kilowatt hours next year. And this takes into account rain days and all kinds of stuff for you. So it usually comes out pretty effective. Now, we did have quite a bit of rain last month, so that could have affected this outcome a little bit too, because it is based on averages. But my point is, if you're looking to build a system and you want to know how much solar panels you use, how much you really need, this tool can give you a good idea of how much you really need to come up with. So if you're looking at a house that uses, let's say, and let's just go for example, a typical house would use somewhere between 1,900 and 2,000 kilowatts a month. So if we wanted to say that we wanted to figure out what would it take and how many panels would I need to do, we can go back to the original formula here and we can say, okay, we're going to fix this, we're going to fix these panels and we're going to put them on a rack in the backyard, and we're going to start off with 10 kilowatts of power, and let's see where we come in. Now, unfortunately, it doesn't kind of let you play around with it, but you can see here, even 10 kilowatts, and that's 10,000 watts of solar panels, all facing at 20 degrees, perfectly facing south, isn't enough really to provide a full energy for that house at 2,000 watts, 2,000 kilowatts per month. So this is what allows you to kind of get an idea of how much you need. Things to consider. This is not going to take into account some of the inverter that you've got, how efficient that inverter is. It's not going to take into account if you've got the wrong wires and they're getting hot and you're losing it through inefficiencies of the wire and you didn't buy a big enough wire. It's not going to take into account if you're using inefficient batteries and you're not, like lithium batteries as opposed to lead acid batteries, the difference in efficiencies there. It does allow you to set some of those factors, if you know what they are, in those calculations and come up with them. But this is just one tool that you can use to come up with an idea of how many solar panels. It will take into account the peak sun hours that you have, and it labels those on here for you, and you can see them here, right here, this solar radiation, how many peak hours you're going to have, and so on and so forth. So it does kind of give you an idea there of what you're going to get out of those while you're doing that. The RV roof, it isn't going to take into account what are you going to do when you have limitations of space. If you're in an RV, there just simply isn't any more space. I solved some of that problem by dealing with building a solar shed so I could get some extra, power out of the solar shed when I'm not moving my RV around, when I'm not traveling and stuff. Usually when I'm traveling to a much cooler environment and I don't need it. Like on my trip to Connecticut a few weeks ago, or was it about a month ago now, we had more than enough power up there to handle it. It's just down here where I've got all the heat, Florida, need the air conditioners all the time. It's also so then you need to make sure that you're watching your panel counts. You're making sure that you hit the right number of voltage to turn on charge controllers within your inverters and stuff like that. But how many you need is going to be strongly based on how much power. Now, the next question becomes, when you talk about this, is recovery rate of the difference between summer and winter. So in the summer, for example, my problem in the summer is that it gets so hot that I need extra power. In the winter, the sun has moved so far out of the sky that there isn't as much power. But those sweet zones in the middle are all wonderful. So that's something that you in your area are going to need to take into account to affect your panels, and that's where that chart can help a little bit. But you can also see the peak ones, they can't determine what you're going to need. So for example, if I look at this chart that I had up here, let me see if I can flip that back there. You can see here, it tells me that June, July, and August are great months for production. What it doesn't tell me is that my consumption is also just as great, and therefore my storage is less than normal. If I lived in a northern state where I still had the great production and still didn't have the hot weather, then I could also count on the storage. So that's the piece that you've got to determine, and a lot of the times you can pull that right out of an electric bill or whatnot. But how many panels you need is greatly influenced by how much power you're going to need to provide for the normal operation, plus how much do you need in reserve I make the joke, for a rainy day, and literally it is for a rainy day. So let me give you an example. If a rainstorm or a snowstorm comes along and you lose solar for 3 days, typically you don't lose all of solar, but you may lose all but 10% on a really bad day and 30% on just a kind of a cloudy, rainy day, and 50% on other days. But if you had a good rain for 3 straight days and you only had 30 or 40% production, how long would your batteries last is the question you need to be asking. And how bad of a recovery time do you need? So I'll kind of explain that, see if maybe I can explain this in a whiteboard. So if you're using 15 kilowatts hours a day, and you have a battery bank that is 15 kilowatt hours, then that means if you have no production for a 24-hour period, then your battery is dead. To have no production is pretty rare. So chances are, even in a hurricane, I was getting 8% generation. So that would mean that as long as I don't have 2 rainy days in a row, then I'm okay. So the question becomes is, how big do you want to make this in order to not have 2 rainy days in a row? And then the next question becomes is, how quickly do you want to fill that back up once you do have the 2 rainy days in a row? So for example, let's say that you have a 45 kilowatt hour battery bank, and your solar panels that we talk about can put in, what is this saying here? If we have 10 kilowatts, probably about 60 kilowatts a day. So if we have a 10 kilowatt hour solar system, on a good day you can put in 6 times that, and on a bad day you can put in 1 to 2 times that. Let's call it 1 times that. So on a bad day you may only end up getting 10 kilowatt hours into your 45 bank. Now, if you're also using 15, it means you're going backwards 5 kilowatts a day. So you need to replenish what your usage is this 15, plus you need to add to the bank in addition to that. So on a rainy day, if you're only generating 10 kilowatts at 1x your solar panels, you are actually going to go backwards 5 kilowatts a day. Now, that would be okay in a bank of 45, because on day 1 you would be at 45. Whoa. On day 2, you would add in your 10 kilowatts and you would use your 15, which means you would be at 40 kilowatts. And that means that this could go on for 8 more days, and you're actually good for 10 solid days of rain. That's wonderful. That would be a great way for it to work. Now, chances are you're not going to have 10 rainy days in a row. And if you get a good sunny day, let's say that you do this on day 1, you're at 40, day 2 you're at 35, day 3 you're at 30, and then you get a day where you're going to get 4x. So the sun comes out, but it doesn't stay out all day. So instead of getting, 10 kilowatts, you get 40 kilowatts. So if you get 40 kilowatts and you use 15 of it to run your house, that means that you're down to 25 kilowatts back into your bank. So if you take this, that puts you at 55 kilowatts. You are full again on day 4 because you got enough sun to completely recover. So 10 kilowatt system getting this type of power when you're only using 15 is wonderful. Now, the fact is, using 15 in a day is not a practical number. I use 20 to 25 in my RV. So, and most houses use between 30 and 40 in a day, and you could use as much as 60 to 70. So, and a 10 or a 12 kilowatt system can still produce, up to 60 kilowatts a day. But if you're using up to 60 kilowatts a day, that means on your peak days, you're going to use everything that you generate. And that means that you need to have a big enough battery on those days when you're not generating that peak that you can store. And how much you store depends on how much you use every day and how much backup you want to have. So here in Florida, going 3, 4, 5 days with rain every single day is very rare. We may have rain every day, but usually it's like you saw in those charts that I showed you earlier. If I could pull one of those up for you. You saw in one of those charts, let's see if I can do that, like this one here, you can see all these ups and downs that I've got here where the clouds come in, the clouds go out. That's a typical rainy day for us. We don't get the like in Dallas, when I lived in Dallas, sometimes you would get rainstorms that would last, where you'd have thunderstorms for 3 or 4 days in a row, and the sun would never come out. I've seen that when traveling up in Seattle, it goes like that also, where you just get clouds for 3, 4, 5 days. Up north, you could have snowstorms that last for days on end. Here, I don't get that too often. So you need to know what that window is. If you have 20 kilowatt hour usage a day, then the best rule of thumb that I've come up with is to go somewhere over 2.5 to 4 times that usage. So that means that if you have 20 kilowatt hours of usage a day, you want somewhere between 50 kilowatt hours of batteries, and 4 times that would be 80 kilowatt hours. Now that you know how big your battery bank is, then the question becomes is how long can you wait for that bank to be full again? Because you may very well only get 1 day of sun and then it go back to raining again. So it's kind of a game of gambling where you have to have a big enough bank to put this solar energy in so that when those rainy days come, that you have enough in the bank to be able to withdraw from it until you get enough, until you get a large enough deposit to fill your tank again. And that deposit, so you could theoretically say, oh look, I use 15 kilowatts, or I use 20 kilowatts a day, and I generate 25. So I'm going to be fine. I generate 25, I use 20. But that technically means best case scenario is you're going to add 5 kilowatts to this bank every day. And that means that if you're only adding 5 kilowatts to it, if you've run it down to let's say 10, or let's say it's 20 kilowatts is in this bank, and you have a day where you only generate 5, it's empty. And when it's empty, it's empty. Everything shuts off. So, and then you're going to generate 25 the next day, even if it's perfectly sunny, and then 25 the next day after that, and then it's going to go from having 0 in the bank to having 5 in the bank, and then day 2 it'll have 10 in the bank, day 3 it'll have 15 in the bank, day 4 it'll have 20 in the bank. Well, if you get another rainy day after that 4-day gap, you're back to 0. So 25 generation probably isn't enough. How much is enough is going to be a question for you to answer, because you're the only one that knows how much that rain is going to affect you in your area. For me, I don't have too much trouble with, I have a 30 kilowatt battery, 30 kilowatt hour battery. We use between 20 and 30 a day, but I do have grid as backup power, so I don't have that. And if I'm traveling and I'm out, boondocking somewhere, I have a generator for backup power. So it's not necessary that you deal with it every time, especially if you're peak shaving, your peak hour shaving or something like that, where you know that between 5 p.m. and 10 p.m. your electricity costs 10 times more than normal, and you just want to make sure that you have power coming from your solar system between 5 p.m. and 10 p.m. That's very easy to do, because you just basically don't use it during the peak hours of the day. You use the grid then, and you can accommodate making sure that you're using solar at this point. So this is the number of panels that you need is very dependent upon 2 calculations that you really have to come up with. One is, how big is your usage? 2, how big is your backup bucket, and how long can you take to fill it? I can fill my backup bucket at about 10% a day. If I have really bad storms for 3, 4, 5 days in a row and my battery gets down to almost nothing, and you can see it happening, going down 10, 12% a day, and then all of a sudden the sun starts coming out and it starts going up, the peak, the top of it is 10% higher every day, consistently over and over and over. I'm okay with that because the risk is relatively low. Now, if I was off grid and I was, living with my family in the middle of the woods, it would be completely different. My battery bank would not be 30 kilowatt hours. It probably would be closer to 100 kilowatt hours, so that I could have that week or 2 weeks in there where I didn't have to worry about that gap of things running out. Now, so seasonal differences are really, really huge. The biggest trick here, and what they call, quote unquote, the golden rule, is that more panels is usually the cheapest way to solve a lot of problems. It solves the problems of, how much electricity can I use during the day? You run your dryer during the day. You run your cooking during the day. You do all of this stuff during the day, your peak usage, and you do it. If you have more panels, even if you can't store the energy, you can use the energy right then and there. Then it allows you to store the excess energy, and you use your batteries for backup days. More panels allows you to recover faster. More panels allows you to do things during those peak hours and automate things to happen. For example, turn on well pumps and pump water during those peak hours, as opposed to storing that energy. You pull the water when you have the ability, and you have tanks to store it in, as opposed to you run it. It depends on if you're running in a cabin in an off-grid situation, or if you're running in a big city and you're just trying to shave off some high rates and stuff. So a lot of those elements come into. So how much do you need? The best rule of thumb is as much as you can afford, but there is a limit to how much you're using versus how much you need to actually be able to recover. And that's where you're going to have to draw the line and say, use that formula, use that website that I had to basically give you an idea of what those are, and can you use it to give that calculation and understand how much solar panels are done. Oversize where you can. Don't plan just for what you have today. This is a really common mistake, as people say, oh, well, I'm only using 5 kilowatt hours a day, therefore I'm going to generate 5 and I'm done. It never works that way. As soon as you have what you absolutely need, you're going to want, you're going to want to cook an extra pot of coffee. You're going to want to leave it on instead of shutting it off every time. You're going to want to have an extra bath and have the extra hot water. You're going to want to leave the big one for me is I don't mind turning the hot water off and on when I need it, but it just drives a family crazy to have to know when to schedule hot water. And I'm going to do dishes, I need hot water. I'm going to do this. So to be able to just leave it on and know that, hey, you're going to burn a couple of extra kilowatts a day, and that's legitimately, I can say that that's exactly what I've done this summer, is to find out. I come over here into the energy board and roll down here to the bottom. I can legitimately say that the hot water heater here is, bad example, hot water heater is accounting for it's got a reset in there of some craziness. What is today? Today. So, hot water heater is 2.4 kilowatts yesterday. And I go back again to the day before, it's 1.9. So it uses about 2 kilowatts a day to just have, and here we got 3.7 kilowatts. So it uses a couple of kilowatts a day just to keep hot water, even if I don't use any of it. Now, if I use it, as you can see here, that usage is almost doubled. Now, who knows what that was? Could have been a whole bunch of laundry, could have been a whole bunch of extra showers, or, who knows what it was. But that's the thing, is understanding that energy math to know what it is and how you can use that power the right way. But solar panels are usually one of those where the more the better, because it makes all your recoveries easier. So I've provided you the link to that is in the QR code here. And if you have any questions, I would love to if you do your calculations differently or you come up with something different. I use a general rule of thumb. I'm going to pretty much can guarantee I can get 1 times the solar panels I have, and the peak is going to usually be close to 6 times the solar panels I have. That's just a simple rule of thumb. If I got 2 kilowatts of solar panels, 2,000 watts of solar panels, then I'm going to get somewhere between 2 kilowatts a day and 12 kilowatts a day from those solar panels. It's just a simple rule of thumb I use, and it pretty much applies to everything. But it's going to vary based on how your panels are all set up. QR code for those that are watching it on TV. You can just scan this QR code; it'll take you there. Or you can do it on your phone. If you're watching, then the links in the description below. Also, you can get to them there. Don't forget to subscribe to the email list, because I'm going to have some cool stuff coming out in the email list, and only those subscribed to the email list is going to have it. You can find the links for that down there. And the panels, I just want to kind of remind you, the panels are really the foundation of your system here. And you can build a system around panels knowing how much power you need. Sometimes it's the inverter you start with, sometimes it's the panels. It really just depends on the system. If you're like in an RV or something where you have a very